Good morning, mathematicians. I hope that you had a fabulous weekend. Today, we're going to continue talking about fractions. We're going to use the thermometers. We're going to talk about number lines and fraction strips. So, even though we will be working on problem 1.3, I have consolidated everything into these Google Slides because we are going to skip just a few of the questions. I've also done some of the work for you here on the slides just to make it a little bit easier. So the sixth graders made their own fundraising thermometer to record their progress. At the end of each day, they compare the total amount they have raised to their goal. The shaded part of the thermometer represents the fraction of the goal that the sixth graders have raised. Their challenge is to figure out how to represent dollar amounts as a fraction of $300. They make fraction strips to help them correctly shade their thermometer. So I am going to leave it entirely up to you as to whether or not you want to make these fraction strips. There is a tutorial that shows you how to make them, but I have really provided you here with enough graphics and information and diagrams that you really don't need to, although it is kind of fun if you would like to. If you were in the classroom, we would be making them. So it's really up to you as to whether or not you'd like to actually physically make them with 8.5-inch strip pages. So we have a question here, and that the question is, have the sixth graders collected more than 1/10 of their goal? How about more than 2/10 of their goal? So what I've done here is I've created a 1/10 fraction strip here, and you can see how they've already provided us with a 1/6 fraction strip. And when we look at that, we can see that out of their $300 goal, when we look at this next to the 1/6 strip, we can see that they have definitely already raised 1/6 of their goal. So the question is that more than 1/10? And you'll have to answer that for yourself right here as you're looking at these 10th strips. You can compare. And how about 2/10? Is it more than 2/10? So here's some strategies that you can use if you are going to go ahead and fold up those strips. You can think about how to start. So for example, if you are going to make any even numbered strip, so in other words, halves, fourths, sixths, eighths, tenths, twelfths, you can certainly start by by folding the fraction strip in half. If you are using any multiple of 3, thirds, sixths, ninths, twelfths, and of course, obviously with sixths and twelfths, they fall under both the 1/2s and the 1/3s. But you can begin, especially when you're talking about the ninths, right? You can begin with thirds. So just lots of different strategies to use in order to fold up those fraction strips. The picture below shows a student's halves, fourths, and eighths strips. How does the size of one part of a half strip compare to the size of one part of an eighth strip? So the question that we're being asked is, what is the comparison? So from here to here, so a 1/2 strip compared to a 1/8 strip. So think about that. We're comparing it. How does the size of the half compare to the size of 1/8? Any idea? So I want you to think about that, and you can create a text box right here to explain your answer. What I've given you here are some fraction strips. You are more than welcome to use this slide to answer all of the questions. So if you did not go ahead and create those fraction strips, or even if you did and you feel like they're really not all equal parts, please feel free to use this slide in that way. What fraction strips can you make if you start with thirds strips? Can you make sixths? Can you make ninths? And then you're going to just answer this. I don't think I created a text box here yet, so I think you're going to have to create your own text box on this one, this slide number 4. And you're going to answer this question. Can you make 1/12 fraction strips if you start with 1/3? How about 1/10? And then it says to explain. Oh, yeah, no, I think I already do have the text box there. Which of the fraction strips you folded have at least one mark that lines up with a mark on the 12th strip? What equivalent fractions do the matching marks on the strips suggest? So what you're going to do is to take a look here. This is 2/12. So we're going to move along here to see if any of these, oh, well, look at that. 2/12 is equivalent to 1/6. So in this text box here, you would write 1/6. For this one, for 3/12, we kind of want to go across and see which one has exactly 3/12. Oh, look at that. It's 1/4. And wait a minute. I also noticed that 2/8 is equivalent to 3/12. So I've got 3/12, 2/8, and of course 1/4 are all equivalent fractions. I'd like you to do the rest of these on your own, starting with 4/12, and then you can go down to 6/12, 8/12, 9/12, and 10/12. You're looking for those equivalent fractions by lining up, and this graphic is super helpful because they're already lined up. In earlier grades, you used number lines such as the one below to show whole numbers. Well, now we're going to look at a number line and how we can add fractional parts in between the whole numbers. Some students began to make a number line using their 1/3, 1/6, 1/9, and 1/12 fraction strips. The drawing shows their work so far. One student used the top fraction strip to mark 2/3 on their number line. Name 3 other fractions shown here that are equivalent to 2/3. And then it just says to name another fraction equivalent to 2/3. And basically, you can name any other fraction that is equivalent to 2/3. It doesn't have to be posted up here. So this one says shown that are here, right? 3 that are here. And then they just want you to add one. And it does not have to be represented in that graphic above. Some other students began to mark number line using different fraction strips. Use their drawings to measure distances between points. For example, the distance between the mark labeled 0 and the mark labeled 3/5 is 3/5. This is distance. Remember, distance is always measured in positive numbers. We will learn more about that when we move on to accentuate the negative, which is one of our 7th grade units coming up later on in the school year. They're asking you to give the distance between 0 and 7/10, the distance between 3/5 and 7/10, the different distance between 7/10 and 1, and then the distance between 3/5 and 1, and you can go ahead and record those right here. What is the distance between each of these points? So between 0 and 1/3, you'll type that in this text box here, between 1/3 and 1/2, and then the distance between 1/3 and 2/3. And this one is talking all about distance. These are the only questions that you have to do today, along with the ACE problems that go along with this unit. So have a great day, and please make sure you come on over to those office hours if you have any questions at all. Make it a great day.